Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been privy to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between.
How's it going? I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And this week we're going to kind of, jump in the wheel of, still through our 3D printing pieces and parts. And, we're going to kind of touch on, the extruder portion of it. By the way, sorry, allergies are kicking my ass right now. Can't help it. My bad. So kind of sound like Kermit the Frog. But with that, extruders. Extruders are a fundamental part of a printer, if you think about it. It's what gets filament from point A to point B, and then what makes sure that you're getting adequate amount of flow through the hot end, through the nozzle, down to the bed.
Yeah.
Pretty much simple way of doing it. Motor, gear, done. Right? So, now we start talking about extruders. If you think about it, if we think about, so how we want to kind of break this down is there's many different types of extruders. And what we want to do is we want to break those down.
Yeah.
So we want to talk about the dual gears, the single gears, the plus and minuses of both of those, and kind of what they're used for. Also, the direct feed extruders.
Yeah.
So we're going to kind of touch on all three of those. I guess first and foremost, when we're talking about single gear, what do you think?
Yeah, I'm going to be honest with you. Most of your printer out the door is going to be single gear unless they explicitly say dual gear extrusion. I mean, if you're talking single gear, that's your standard Ender 3. I think that most people are going to work with that, but there's inefficiencies that come from it, right?
Yeah.
At the end of the day, when we boil it down to what is an extruder, is it pushing your plastic through the hot end, like through the Bowden tube or however.
Capricorn.
With you have preferably Capricorn. It's something about the PTF tubing of Capricorn. It's so much better. Now, when you're thinking about a single gear pushing that through the PTF E tube, there is like friction is heavily in my mind.
Mm-hmm.
So you have one single gear pushing the plastic. It needs to be able to catch and push through and not
bind up.
Bind, or the friction from the PTF to E tube cause it to like get stuck in the nozzle. Honestly, like the worst case scenario, you get a clog, and that clog is at the heat break, so it's just close enough to where a little bit of it melts out, but it's too far to like be completely melted, so then it molds into a blockage, and then you can't pull it out or push it through. That is usually what
Where the issue is, yeah.
Yeah, it means you need to tear down your hot end, and that's not fun. Or crank the heat if it can take it.
And the thing is, if you think about it, extruders are also, especially single gear, is limited by the type of filament that you can run.
Mm-hmm.
So, you can either run a dual gear, the thing is, with a single gear, pretty much stuck to PLA, ABS, and some of your harder filaments at that, but I don't think it can print some of your softer.
Nope. TPU? Nope.
Or TPE or whatever it is.
None of that's
extra flexible stuff.
Well, you think about it, and I'll toss it over to you, Ed, as well, because, like, for me, I view it as, like, it's a physics, like, you can equate it to a physics equation. Like, it's surface area.
Right.
Like, how much surface area am I able to impact on this, tube of plastic, or this roll or spool of plastic, so that it moves, and how much is too much? How much is not enough? And there is a sweet spot.
Mm-hmm.
So, I mean, what do you think about, like, how that kind of functions.
I think the big thing is when we're talking single and dual gear, it's like I said, it is contact. But if you're running PLA, you just started. Most of the times, it's either you are using material that's inferior, either you've made some adjustment to the mechanical tension that holds the friction on the bearing that's supporting one side of the filament, or you're when you're pushing out the material, maybe the nozzle's not hot enough. Maybe you're not at the right temperature, and that can also have an effect because it's not solidifying or liquefying. Excuse me, not solidifying, liquefying quick enough.
Right.
So the viscosity is not correct.
It's not going
which
from
means
liquid
that
from a solid
you're
to
trying
liquid.
to feed, but you're binding.
Yeah.
So you have, like you said, there is a sweet spot that you have to make sure that the liquefaction of the filament and the speed and also the tension that you have on that particular filament and the filament itself are all, I would say, ideal. Because if not, you're going to run into problems, even with PLA.
Not all filaments have the same. They're all polymers. They're all plastics, but PLA from one brand it does not equal PLA from another brand. Also, PLA from the same brand, you know, if you had it got it like a year ago, might not be the same composition as the PLA now as well.
Right.
So,
Then you start dealing with like recycling PLAs and stuff like that. Then you never know what the heck you're getting your hands on.
yeah,
You know, but the thing is all of that, you know, is written on the box most of the time.
Please.
You know, they put it on the box. They kind of tell you what temperatures you need to have, where you have to run at, you know, and stuff like that. So that's something, you know, that is a world of help to hit that point. They also put a warning on there if you need to have certain things to be able to print, you know, their material and stuff like that. So, you know, with that, we kind of, you know what the pluses and the minuses are of a single gear extruder. So, you know, it's like if you had to go back and do it again, would you run the single gear to start with?
Oh no, hands down, I would have gone to a dual gear immediately.
Yeah. Well,
Immediately.
I mean, we have to remember, you know, the birth of the, 3D printer was basically a hobbyist machine. So when you start talking about changing, you know, mechanical ratios and changing the actual physics of something, that's going more from hobbyist to more commercial or industrial. So that was born out of people who want to use other filaments outside or exotic filaments instead of just using PLA.
Yeah, the rep movement.
Yeah, so I mean, I mean, of course now it's probably more advantageous to have dual gear. I mean, no matter what filament you're printing, more contact surface is better. But I do believe, you know, even with the dual gears, you still have to take into consideration all of those things we said. The filament itself, you know, the E-steps from, you know, the extruder you're using, you know, the speed that you're running, you know, the nozzle. So if I run a bigger nozzle, okay, now I can push more material. So how does that affect the feed rate? So all those things you have to take into consideration, even with a dual gear.
Yeah.
It's good that you mentioned the feed rate too, because I don't want to take too much of a side diversion here, but we talked about, you guys have actually seen probably the single point lesson for the bed leveling, but there is also should be soon a single point lesson for the flow rate. So adjusting flow rate in Clipper, adjusting flow rate in with your standard, you know, Marlin firmware too. Like, they're not the same thing. They're named differently, so you're gonna have to be careful. But that's something that should be relatively easy, and it will affect your print.
Yeah, it's going to be on one of our next videos that we're going to do.
Yeah.
You know, I know we're going to start talking about a lot of nozzle stuff too soon also for some single point lesson videos. And then we'll get into, you know, backing our way up into the hot end extruders and whatnot until we get to where we want to be. You know, that kind of leads us, you know, down that magical rabbit hole. To the next step, you know, pretty much the next movement, you know, for these things is to your dual gears. You know, once we go into dual gear extruders, you know, you start dealing with more of your advanced, you know, extruders on the market. You know, right now, more, you know, there's probably some more out there that, you know, they haven't really, you know, dinked with yet. And I'm sure they'll get to it.
Yeah, if it's quality, it's going to be a dual gear.
Yeah.
Just, I'm thinking, I mean, all the things that you mentioned earlier, Ed, as far as the benefits of having a dual gear, also with the added benefit of, you know, if you have the same motor, it's going to have to be working twice as hard if it's got single gear.
Mm-hmm.
So you're working down, maybe not completely in half, but you're working down that engine or that motor's lifetime, or maybe that gear is going to go out quicker than this dual gear will. So, yeah, and of course it does matter what that tension is, but at the end of the day, the wear and tear on your parts are going to be what frustrates you most.
Right, and the ability to print the fun stuff, like, you know, TPU, and you can start really printing that really slimy TPU, and one that I saw the other day, it's a foaming TPU, that when it prints, it foams.
There's also like the ones, isn't there the one that's like the dissolvable?
Yeah.
As well supports. That's pretty cool.
And it has to be printed with a dual gear extruder because it's about the same consistency of TPU, or you know, at least the ones I've seen. Some of them might be, you know, same as PLA.
Yeah.
You know, which could be interesting.
Yeah. I think another thing to consider is like whether it's a all metal extruder or if it's, you know, plastic and metal extruder. I think that plays a part too. You know, it's more robust. The other thing you have to look at is the distance from where you're pushing that filament to your heat break when it goes into, you know, your actual, from there into your nozzle and so forth. So you have to look at all of those things too. If you have a big distance between it, then maybe it's more likely that you can have a jam.
Yeah, I think a dual gear, single gear, to me that's still Bowden tube tech, right? So like we can definitely like those. It's moving in the right direction, but I think the extruder can even evolve even further. Yeah. Because you just kind of brought up the piece, like how far am I bringing this filament to the hot end? How far what is that distance? And at the end of the day, your motor's doing more work if you have to push it through, you know, a 2-foot tube, as opposed to what I would say would be the next natural progression is a direct drive.
Mm-hmm.
Now, necessarily, the direct drive doesn't have to be a single or a dual, preferably dual again.
Yeah.
But like whenever we're kind of talking about, if you hear single gear, dual gear extruder, and they don't tell you direct drive, it's going to be a Bowden tube. And to be honest with you, direct drive might be a better option. But it just depends on your situation too, though.
Exactly. It's like, you know, some people can't like for example, all your enders are all going to be Bowden tubes. Most of them, at least. Most of them. Your basic ender 3s, ender 5s, and all the other fun stuff will be a Bowden tube setup. It's going to have the mile long, you know, Capricorn tubing in between, you know, the hot end and the, you know, extruder. Mm-hmm. You know, so, but, you know, I think, you know, we'll definitely hit the direct drive stuff. But like you said, it's also a space thing. Because, you know, direct drives, you need to put the filament up top or somewhere where it can, you know, feed, while others you can put it in a different location, feed dry box, and it's just going to, you know, take it as it needs it.
Yeah.
And then, something we didn't touch on.
That's true. Yeah.
The anatomy of the extruder. You know, basically you're looking at gears, motors, and teeth.
Yeah.
And it's a ratio.
Yeah. Right.
Normally it's 3-to-1, I believe.
Yeah.
You know, so that's another thing that you should verify and look into when you're buying an extruder.
And calculating that stuff out is fun.
Because maybe you have to mess with E-steps or something, you know.
Right.
Because this one is maybe not adjusted correctly.
Right.
I mean, you may have to do some adjusting on the extruder straight out the box. It may not be just mount it and run, you know. That may not be the case all the time.
Yeah. Some printers, on the other hand, like, you know, some of your enders and Pruses and stuff like that, might not have to adjust as much. and they're already preset in their firmware because it's based off of the filament that it knows you're going to run, which is going to be PLA or ABS.
And
So
God forbid if you run a Cura.
That's what a lot of people started on, man. That's what a lot of people are
But
using.
God forbid.
I mean, I'm not a fan, but I mean, I can see how it was used.
I'm just saying. I mean,
But it's
you can adjust your flow rate on in there too.
we're just
Yeah,
gonna
make
talk
that big
about you need
mistake.
some quality of life improvements. That's all.
Yeah.
Well, if
Ed's
you
got
like a
some-
challenge, then Cura maybe.
There's some people out there that are diehard Cura users.
All I'm saying
tell you that right now.
is Ultimaker Ed Brown's got some notes for you. He'll send you an email shortly on how you can improve.
It's probably going to be right in your
Your
delete
software.
box. But
Yeah,
I mean, maybe when
you
we
should take it
first-
seriously.
when we first started with 3D printers, that was the avenue to go. But like,
Yeah,
there was a lot of other software out there now that's more flexible.
the funny thing is most of it all came off of the Slicer program.
yeah,
That's where it all derived from.
it's true.
Most of the time, there's still people that use that too.
Yeah, I mean, for what it's worth, there is a line of complexity too that's for some people is, when you get into those like super slicer or those special ones that like, you need clipper or you need it for clipper or this or that. Like Prusa is a safe Prusa slicer, I should say, is a safe, place for a lot of people to kind of jump off from. But like once you get into those specialty niche things, like it'll do most of what you need.
Yeah, and the thing is most of the time you also have the save settings, stuff like that, your save profiles. That's before we even get into the SVOL type system and stuff like that. The SVOL is just a Prusa knockoff.
Yeah, and configuration.
But same
exports
configuration.
work,
Well, here's the thing: if you're getting into 3D printing, and you're new to it, then basically you're probably not gonna make a lot of changes in the beginning. I have not. But how many people have a microwave? Who goes and reprograms the firmware on the microwave?
You do every time you change the clock. I'm just kidding.
You do it,
That's pretty much it, though.
I mean, or the refrigerator.
Yeah,
A
you're not
smart
going
fridge.
and changing what
I said
those
so.
buttons are doing.
If it's an appliance and the appliance is used the way it was meant to be used, that's fine. But if you're tinkering and you're trying to get performance out of it, or you're trying to say, well, what can it do? Basically like you're doing a bench test. If you're doing a bench test and you want to get the most performance out of it, then of course you're going to mess with those settings. Yeah. So Cura is probably okay if you just want out of the box and just print, normal PLA, items.
Yeah.
Mm-hmm.
But if you're trying to, do PLA plus and do some fancy bust, or maybe you're trying to do a statue, then maybe you're going to have some issues and you're going to have to make some changes.
Yeah.
Or maybe you've run the nozzle for 6 months and you didn't pay attention, and now the diameter is larger. So
it's
now,
flat.
So those
it
are
happens
things.
a lot more than you think.
Yeah, so I mean, eventually you will have to do something to the printer other than print.
Yeah. But it's one of those things where it's going to happen. The theory is of it is what it is. And it's gonna be it is what it is when it gets to you, because you have to deal with something.
It was what it was.
Yeah, especially when everything disappears.
Yeah.
It's things stops when one thing goes to another. So I kind of want to I think our longest portion of this entire conversation is about ready to happen.
Oh no, yeah. There's more.
Well, it's the fact that now we can transition from that, because most of those printers we just talked about are also all direct drive. So now we can hop into the wonderful world of direct drives.
Yeah.
The fancy dancy stuff out there.
I was gonna say it gets a little weird.
Yeah, and it's a little weird.
The reason I say it gets a little weird is that like,
what is it, the big 3D thing that you can actually? It's a extruder, hot end, all built into one package, and it's about the size of a dollar bill.
Yeah, you get everything all in one.
But now you got the ones that's the big 3D, water
cooling.
The water cooling.
Like you got a little water cooling loop that you have set up, which is wild. Like that's crazy. Why? Okay. I mean, I guess it makes sense if you want to keep.
But
temp,
before we go down that rant,
industrial right here though.
'cause I have a feeling that one's going to lead to a rant.
Oh yeah, it will. It will.
It's going to lead to a discussion. So, first and foremost, the benefits.
Okay.
We'll start with the actual, I guess, path we want to go down before we start having our big 3D conversation. Because honestly, I'm not gonna lie, I kind of want one. Because I want to see how this thing goes.
Kind of want all of them though.
I want to try it just to see if it's if
one of each.
everybody says the damn thing's great, so I'm willing to give it a shot.
Well, the E3DS mirror is one that they're talking about now because it cut that distance that everybody else still has.
Yeah.
There is no distance from the extruder to the heat break.
That's also the one that they're. Who makes Chimera?
E3.
E3. Oh, okay, well then no, I was
That's
thinking Mosquito, but that's hot end.
10 kilograms of pushing.
Yeah.
And then it's like 73 to 22 gear ratio.
Okay.
But
so like it now I did see a review and the guys did complain about when you get a jam.
yeah, taking the thing apart.
Yeah.
That okay. So let's get into that real quick.
Yeah.
So the benefits of a direct drive. A little bit closer to it. A little bit easier to maintain. Well, not really. And it's not as compact as you think it is.
But it was faster.
It's
It
not.
is-
as,
it
was
faster.
60
It's much
where
faster.
everything else was 30.
Yeah, it's much faster. I think that was one of the key things is you're eliminating that tube. You're eliminating the distance it needs to pull or push. However, with that, any deficiencies are shown immediately.
Yeah, exactly.
So if you get a bit of a skip or if you hear a click and the gears skip at all, then you're gonna notice immediately in your print there's a defect.
Yeah, there's delamination.
Yeah, so that's the worrisome part for me. But the nice thing is honestly, if I'm looking at it, it's very seamless in what that is, and in a lot of cases, you can set like the filament spool up above, and then it's just using gravity to really do most of the work, as opposed to sometimes the dual gear extruder or the single gear like standard extruder with the Bowden tube is working to spin your spool and pull the plastic.
Mm-hmm.
And the thing is, it's also
if you that's a piece.
If you use a direct drive, you can actually make the package smaller.
Yeah.
You can theoretically make printers smaller.
Yeah.
Because there's not that much going on. And the thing is direct drives are great. I got one on the Voron, and I got that one on that, and I got a Bowden tube set up on the Ender 5, and I'm gonna tell you, I already noticed the benefits of the direct drive, because I can easily swap out filaments without even thinking about it.
Yeah, I mean.
But then again, that's a whole different bag of nails.
I hate to be like the one that just beats the Bowden tube down just continuously, but like.
Stealing's lunch money.
One piece of one of the issues that I have with the Bowden tube is if you're not doing Capricorn, which if you got the basic stuff, you didn't get a Capricorn Bowden tube, you got the stock, like white tube. If you try to print ABS, you're gonna not only be melting your filament, you're gonna be melting your Bowden tube.
Yep.
So that's too hot for your Bowden tube. So not only does it give you going to direct drive, gives you less of a chance that the tube melts because the tube's not there. That's to say there's less of a tube
and not the cold end.
Yeah. So there's less of a tube there too. So actually, because there is a bit of a tube on direct drives, but it's
for example, like mine, I switched mine out. It called for Capricorn tubing, not Capricorn, but it called for PTFE.
Yeah, put some Capricorn
tubing on my Voron. When I built the Voron, I used Capricorn tubing inside the hot end.
Yeah.
Just to make sure that was taken care of. I didn't have any issues there and whatnot. Yep. Now I feed my extruder with a PTFE lined tube, but that's only because that's what they recommend and that's what feeds to the hole.
Yeah.
So, because some people are using all metal there now too.
Yeah.
Oh yeah.
It'd probably be a good idea. I mean, honestly, where you can use all metal, like because there is a direct drive kit that I have for my Ender that I got for my brother the other day, and So it's all metal. The whole thing's metal, but you relocate everything that you currently have onto it and mount it in the place of where your hot end is now.
Oh, okay.
Yeah, but
It's like a relocation bracket.
yeah, but you're right. It is bigger than you think, and you take the motor that was on the side, and it's not on that other gantry on the counterweighting something. It's in the center now. So if you have not a dual Z lead screws, you don't have two lead screws, you risk some type of angle shifts or issues like that.
And the thing about having the extruder out on the arm is that's a little bit more weight. And depending on the movements you're trying to do, sometimes, when you're trying to do those movements, you may run into issues. Just because it can only print the liquefied plastic as fast as the stepper can move.
Yeah.
Repeatedly.
Yeah.
Most of the time it's okay, but say it's something you have to make a fast movement on, then maybe maybe you have some problem with that extra mass.
If you're going straight out of the box, like trying to do fast prints, you're gonna have issues if you don't mess with your retraction settings. So when it goes from one layer to the other, and when it crosses a perimeter or anything like that, if it's not if you're not retracting your tool head and retracting the filament a little bit, you're gonna have a bit of artifact when you come back on the next layer.
It's just the big thing is if you're gonna go direct drive, make sure that your setup is kind of ready for it. Make sure you have extra supports in there to hold it steady so it's not moving around. Make sure your speeds are set up, everything is set up. If anything, go to a top gantry, system kind of like the Ender 5, or go to a Core XY type of system that is running on the Voron. If you really want to go to a direct drive, most people are really good about direct drives. On like Ender 5, on the Ender 3s, because they have dual gear, dual Zs. They have all that stuff set up. They have the extra kick out supports ready to go because it's holding it steady. You're playing with leverage here.
Yeah. When you're saying dual Zs, you're talking about two extruders, right?
Two gears.
Two lead
lead
screws.
Oh, dancing.
On your
I
Z,
got you.
yeah.
So basically, where do you fall on dual extruders? I mean, we already talked about
that's a whole
So-
bag.
Without getting into a whole nother topic, just general.
Well,
The thing is, it
what
still
do you
falls
think-
into.
How do those two things work together?
so
If I'm doing a print with those two,
to appease both you guys, I think it falls under the extrusion top.
I think it does too.
I agree it does. I think that it falls under special cases.
Exactly. I just think it's outside the realm of a single gear, dual gear,
Oh, yeah.
or a direct drive.
because now you're talking like
Right. Now you're in a
advanced,
specialty
yeah,
drive type
yeah.
of setup.
So it's not like a hurdle that
extruder.
you need to leap to be a professional at printing or
Right.
get proficient at printing, but it is a hurdle, like a side step that you can do. That's pretty impressive.
And it's on. And the thing is, it's on your. And the thing is to make it work, to make a dual gear extruder work efficiently. It's all in your slicer settings.
Yep.
So here's the question.
It's true.
So if I want to make two different colors,
You better have two nozzles.
no, if I have two
don't have
separate extruders,
Yeah.
right, running dual extruders, I've seen that, so I want to do a multicolored something, a statue.
Mm-hmm.
I want to have light and dark so I can have contrast to show off the contours of that sculpture.
Mm-hmm.
So normally, the old way you would print, retract the filament, purge the filament out of the nozzle, put more new filament in there, do another purge, run a test to verify that your height is right.
Mm-hmm.
Because it should normally be half of whatever the filament, half of whatever the diameter of the nozzle is. That height. So say 0.4, you're talking 0.2.
It depends
for the height.
Depends on what you slicer. You can change it in the slicer.
Yeah, but normally they recommend at least
standard,
half.
Mm-hmm.
But if I wanted to do that, normally it was more work. But with two extruders working at the same time, printing different portions of the print, or I want to do batch printing with two of them. I want to print a statue. Hit prints, one extruder prints half, another extruder prints the other half, and I assemble it. It's less time. So, what do you guys think about from that aspect? It's specialized, and it's kind of getting off topic a little bit, but how do you guys feel about the possibility or the potential for batch.
Oh, I think it's
Printing.
case by case. I mean,
Yeah.
I'm gonna be honest with you. They're doing this. There's like, have you looked at the shear honor? How big the? So here's a bed the size of the ender, which is about, I want to say 7 by 7 foot or inch. Sorry, board. I've seen printers that have 4, so each one has a quadrant on that bigger bed, and each one's doing the same print. So the main printer motherboard is handling, hey, this is my print, and the commands are being duplicated or cloned to all the nozzles.
And that's basically what most industrial 3D printing applications, that's normally how they're working.
Yeah, and if I looked at it in an industrial situation, if you're doing that and kind of doing like like the pick and place next, if it's printing those things and then moving next to the pick and place robot, that's
the only difference
your part
is
system.
you're not using steppers, you're using servos, and servos are a lot more accurate as far as repeatability and feedback with whatever you're using. You know.
Well, that's when I would go to like your the belt kits. You know, if I was to do like a pick and place setup, I'd use a belt kit that pulls it forward and then you'd be picked off of the belt.
Yeah.
You know,
or
instead of just a
do
bed.
it,
That
do
makes
what some
sense.
people do with gravity.
Yeah.
You take
Just
the
let it
belt,
take it away.
let it go to the edge, and it falls into a box.
Yeah, but you know the thing is if you're talking about dual extruder, dual nozzle, you know, setup, you know, I've seen some of them. Yeah, they're called the duplicator series.
Yeah.
So they kind of duplicate whatever the other one does, right? I think some of them you can find them on Amazon. I think they're a duplicator series that does that. I've also seen people do it. I don't know how, but you know, they're working some ghost magic, doing dual stealth burners on a Voron of my size. So you got 2 nozzles printing the same thing every single time. 2 extruders because they're both direct drives.
It's got to have a stationary position that's out of the way somehow. That doesn't make sense.
No,
Okay.
they move on their own.
I gotta see.
Well, here's the thing that like I said, and then we probably.
But now here's the thing. This is now where you can really get into a funny situation here. You can get your dual extruder, but you're gonna do a Y nozzle.
Yeah.
So you'd have 2 colors coming to the same nozzle.
Which that would be a good benefit too. But what if you could do that do the same thing with 4 extruders? So now we're getting crazy.
Well, then you get like an MMU.
With a
So-
wide nozzle.
So by the way,
Then you get like an MMU.
you said you're getting crazy, but we're talking specialty like extruders, and like there was a research project done at Stanford. No, I think it was Harvard. It was Harvard.
One of the schools.
Yeah, it was one of the Ivy League schools. But
One of the special people schools.
she was trying to print while twisting the filament.
Oh yeah, we saw that.
And she had 4 filaments coming through,
Yeah.
even though they weren't conventional like a spool of plastic.
understand
They were
that.
like liquefied, like resin type, like cured. So I
Yeah.
mean, listen,
Well, we're getting crazy. So
that's like bleeding
Yeah.
edge though. Like
If you really want to get into something, there's some dude on YouTube right now. I saw his video the other day. He is trying to take the resin that you'd put in a resin printer or something thereof and printing it with Ender 3.
ain't gonna work. You need a black light or something.
No, he does. He has one attached to the hot end.
Okay, well then it's gonna work probably.
No, not very well, but it works. It does something.
It's gonna cure.
But
it.
the thing is that's still an extruder.
yeah. Well,
It's just a vacuum pump.
here's a thought, and then I like I said, we probably want to
That's
get
funny.
back to the topic because we did go off just a little bit. So
That's fine.
2-part epoxy, right? So 2-part epoxy basically it's a polymer, right?
Yeah.
You know, you take this substance and this substance, put together in parts.
Yep.
So what if you were able to do that with extruders, 2 parts of 2 types of material, and have them react with each other to solidify?
Sounds like a bad time if you have a leak.
So
Yeah. Well, if I got 2 extruders, so the point is you have 2 tubes.
Okay.
Like with the epoxy, you would have to either have 2 tubes or 2 separate
Yeah.
components that come together to make that. Then maybe you could start to maybe the metal aspect that everybody trying to get to could be easier. Because basically they take a binder, right?
Yeah.
They take a powder, and then that powder is mixed with like a binder, and then that binder is formed, compressed, and then it's put into it's annealed basically in the oven.
Yeah.
But what if you were able to do those things, with a printer,
Yeah.
with different? I have no clue as to how that's done. It's just we're having a Star Trek moment,
Yeah.
so we're gonna
And
go
yet,
with
Well,
it.
Star Trek's real, and the future's now because
I mean,
this
it's-
is happening already. By the way,
And it's not Star Wars.
so yeah, it's not, oh yeah, it is what it is. But what's happening is
Hate you people.
what's happening is that
He
like
says that because I'm probably one of the very few Trekkies here. Everybody else hate these Star Wars movies. I'm a Trekkie diehard. Come on now.
well, if Star Wars can stick with one storyline,
It's
and
okay.
stick
Yeah, I agree with
it,
you.
That
Hey.
would be nice.
Look,
I get lost
And
halfway
we-
through. I'm like, where the hell are
and
we?
we're not gonna go down this rabbit hole because we'll be here all
Yeah,
night.
okay, yeah.
But
No.
Star Trek does not have a Darth Vader.
No one cares.
That's true.
No, Darth Vader is awesome.
They got a Kang though.
I got a Captain Picard, and come
Yeah,
on now.
he's no Darth Vader. Anyway,
But
let's
no,
move
yeah.
on.
So, but what I was saying is the future's now, and what they do is there's two filaments. So one is the dissolvable.
Is that the one with the dissolvable support?
That was hard. Why is that so hard to say? Yeah, yeah, exactly. So you put it in like an alcohol or like isopropyl,
Mhm.
and it dissolves away.
Okay.
But you print the supports in that, and then you use a different material and print your structure. And that was the one that had it was the ball that had like several, like kind of like a Russian nesting ball, had a Russian nesting.
Egg.
Yeah, it has more eggs inside of it. It had a bunch of those, and they were all tied to a single axis, and you could spin all of them. So they could
Okay.
spin separately. So it was really cool, but you can't do that standardly without supports. And, I mean, honestly, I've done some things where I've had lots of supports, and tearing off the supports destroyed my print.
Yeah. Well,
Me too.
Yeah,
I guess, like I said, the biggest thing with the
Or I
extruder
can't get the support's off.
from
exactly. It's part of the print now.
Yeah.
I say still from a beginner's point of view, like I haven't had that many issues with the extrude. I got a fun story about it. Something
Just
that
wait
happened
till
with
you
the
get
extrude.
like a couple hundred hours into
Oh, yeah,
it.
I've printed now.
Yeah, I'm not
I'm
saying
probably
that.
close
yeah.
to 100 hours because
Yeah.
remember I've printed some stuff. But the funny story with the extruder was, of course, you saw us do the video where I was giving some steps, and here's the way you calibrate your level your bed and so forth. So I did that. Although maybe I didn't pay enough attention. So I had a situation where I had to change the spool of filament. So I was like, oh, okay, yeah, I'll just, heat it up, obvious. It's like, I'll just pull it out. And I was like, trying to get this tube off. I was like, man, this sucks. This tube hard to get off. Took the clip off, everything. I said, nah. I said, if it's this hard to get off, it's going to be that hard to get back on. I said, nah, I'll figure out a different way. So I kept on messing with it. I said, you know what? Something is not right. I couldn't remember what setting to do to, to reverse the stepper to have it pull it out with the heat. I was like, Something told me, hey, just heat it up and push this little lever. And you push this little lever to move the tension and you can just pull it out backwards.
Mm-hmm.
Of course, I had to feed it back in, I was like, So that was a little bit of an adventure too. So the moral of the story is if you have not changed the filament, it's a little bit of an adventure the first time.
Now,
Yeah.
the funny part is, I think everybody's got an extruder story. Like the first time I built mine, well, and this goes out to Creality and their wonderful geniuses. Switcher wires. Because the first time we built mine, well, the extruder was backwards.
Yeah, don't switch it out of the gate because it might be right.
Yeah, yours might be right.
But if things are doing things exactly opposite, it's not your firmware. It's wired backwards.
Yeah. So you have to pull a pin, reinsert a pin, and pray it works now.
I mean, to me, it looks like it felt like your Ender 5 was built using refurbed Ender 3 parts.
It probably was.
Or, at the very least, a refurb Ender 3 motherboard with the firmware as that, because it was acting like it was set up like an Ender 3.
Yeah, more than likely. More than likely they had the wrong firmware on it. But now I don't have to worry about that because I run Clipper.
Now,
So,
learn your firmware.
yeah.
Flashing it's so easy.
Yeah, and just change firmwares and you'd be good to go.
Yeah.
But, then you can do it all in the firmware settings. You don't have to worry about it no more. But, for me, I think, unless we wanted to get down onto the more interesting ones of the liquid-cooled hot ends and extruders.
I mean,
but
we could do specialty extruders too, as its own like full episode, because
definitely
it's something like the limits are endless.
yeah.
You-
We want to play with a couple of them, so you might see us playing with them
Yeah.
on a test rig on the
We
YouTube
talk
channel.
about innovation, and like these are all the innovative ones. Like, I mean, honestly, we could have talked a bit more on the nozzle and some of the things that that even came out last year at the Rapid TCT convention. Like some of the things being presented there blows my mind.
Oh yeah, and the thing is we'll get into all that. We'll get into a more say advanced episode later on. So, but for me, I think that brings us to the end. So the thing is I want to thank everybody who listens every single week. If you're one of those people that I see the areas pop up, if y'all listen to us every single week, we highly appreciate it. If you're new here, stick around a little bit. It'll be a little interesting. Enjoy the ride. We appreciate it. We wouldn't be doing this if it wasn't for y'all. We keep seeing more and more and more every year, and every so often. And also, if y'all are going to be in Chicago the first week of May at the Rapid TCT event, you might see us walking around in there. You'll see it. We'll have shirts on. You'll know who we are. Come up, say hi. We'll talk to you and pick your brain and you pick ours, and we'll be more than happy to have a conversation with you. And if anything, if you got an interesting story or something like that, we might do a quick episode or something like that, or get you on one of the YouTube things real quick. We'll do something. With that, we hope to be live streaming at least on the YouTube at least once a day. I think at the conclusion of it, kind of as a hot wash. For the afternoon, to say, hey, this is what our target was, and this is, did we accomplish our target, and did we see anything interesting? So, but that's just what I'm thinking. So, I thank you, y'all. I really do appreciate it, and I wouldn't keep doing this if it wasn't for y'all. And go check out the YouTube channel, check out the blog. We're doing some good things over there. But I'm gonna turn it over to the guys, and we'll see you later.
Yeah, so I'd just like to say we appreciate you guys' support. Appreciate everybody listening. We would like to take a poll this week. Maybe you could, in the comments, leave what type of extruder you have on your 3D printer. What's your setup? Your dual, your single, molding tube, or direct? Just a short little comment on what you're running on your printer.
Yeah, that'd be nice. And yeah, guys, same thing. I echo these guys. Thanks so much. It's nice to see people listening. If we've helped like a single person, it's worth it. I mean, just talking to these guys, we've created a lot of problems for ourselves, but we've fixed a lot more. So it's definitely rewarding in what you can do with it. So stay tuned too. We have those single point lessons as well are going to be kind of more important, I would say. They're going to be good for you guys to learn if you're getting stuck anywhere, if you have a specific problem. Because it is where we were stuck and how we fixed it, or what we need to do, or what you should do. So stay tuned for those things, and once again, guys, I appreciate it.
All right, y'all. See ya.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.